Welcome and hello. This is a video exercise in HEC HMS, and in this exercise we are going to be importing gridded data. Specifically, we will be downloading, importing, and then incorporating gridded temperature data as well as snow water equivalent gridded data sets into our HMS model, and then running a simulation and viewing results. All right, so if you want to follow along, I left a link in the description. It is to this page right here, Introduction to Gridded Datasets. And the first thing we want to do is download these project files. So go ahead and click on that zip file and then click Download. Okay, so that's downloaded for me there. I'll go ahead and click the X to close that. Here are my files. What I want to do first is expand the page over to the right a little bit. This is a responsive web design page. And then under the HMS tutorials and guides page, where I'm located here is under the subtitle, Working with Gridded Boundary Condition Data. And if I scroll down here, the page we're on here is this workflows for downloading, importing, and manipulating gridded data. The page we're on is this introduction page, which just has the initial files. It also has some final files, which I'm not going to download, and then an introduction. And then at the bottom of this page, it has two separate parts. There's a part 1 and a part 2. So in this exercise, we're going to be dealing with part 1 only. So you can advance to that part 1 by clicking over here or in the link at the bottom. All right, so here is the instructions. What we also want to do here is download these two files as well. This is the grid download.zip and download. And then the other file we want to download is the one just below it, which is clippingextents.zip, and download. Close that. All right, let's go down here and just get ready. All right, first thing I'm going to do is open up that HMS project zip file, Upper Truckee gridded initial, Upper Truckee River, and then here are the HMS files. So I'll go up one level to the Upper Truckee River directory. And then what I'm going to do is just drag that to a location on my computer that I want to keep it. Okay, that looks all right. So I can go ahead and close that and delete the zip file. What I want to do next is open up that HMS file. And then what I want to do is move the grid data and the clipping data into the appropriate directories. Now the clipping data, I believe, is just a shape file that we'll use for clipping. And that's true. Okay. So I'm just going to drag that into the GIS file of our HMS project, and that's good to go. So I can delete that zip file. And now our grid downloads.zip here. Let's see what's inside here. Grid downloads, and here's some data for grid downloads. So I'm just going to drag this into our project's data directory. Looks like we already have a few things. That's fine. I'll just move that over like that. All right, so I'll close that window and delete the zip file. All right, let's go ahead and open up HMS and open up this project. So I'll go ahead and go File, Open, Browse, and then navigate to our project. Here's the project right here. Here's the .hms file, and then I'll click Select. I'm going to click on this Convert project because the previous project was built originally in a different version of HMS than I'm currently using. I'm also seeing this pop up for missing file references, and I investigated this earlier. It's basically for a file that's no longer used. So I'm just going to say close to that. We don't need it. If I want to find exactly what that was, it was a time series data right here for snow water equivalent gauges, and that was Subbasin USA. That's why we're seeing red text right here in the components editor. But I clicked around the model. It's not used anywhere. This right here is the snow water equivalent gauge that is referenced in our model. So I'm going to open up the basin model and then click on the basin. And now here is our basin map in the model display here. Let me toggle off a few of these layers, view map layers, and then we can turn off some of these just to kind of clean it up a little bit. Here is the subbasin. The outlet is at the north end of the region. It is one subbasin making up our entire watershed here, and we are good to go. Let's go back to the instructions here, importing gridded SWE data. So the first thing we want to do is go to this link at arizona.edu and then download the Water Year 2017 Snow Water Equivalent Map. This is going to be a .nc file, so netcdf. I'm going to open that in a new window here. And then what we want to do is navigate to the daily data for kilometer. And then we want to go down to Water Year 2017 directory. And now I started downloading these. These are the actual .nc files, but I realized that it's a daily record. So after a few records, I decided to not do that. But thankfully, the instructions notify me that these files are also included in the project files above, which should be located in the data directory. So here is the data, and then right here is the file. So this is for the entire year. This would be all 365 days of that 2017 water year combined for the University of Arizona snow water equivalent depth. The next thing the instructions tell us to do here is import that snow water equivalent data into HMS. So to do that, we'll go up to HMS, Components menu, and then Grid Data Manager. We're going to select the snow water equivalent grid, which is right here, and then click New. I'm going to give it a name, UASWE, and then a description, and then click Create. And then go ahead and close that. Now in our grid data, we should have a snow water equivalent grids, and then here is the grid we just created. All right, now we need to navigate to the DSS file, but we haven't even created that yet because we have to import the data from that netcdf file, convert it into a DSS file, and then we can reference it here in our grids and then add it to our basin map. So let's go ahead and do that. I'm going to go File, Import, Gridded Data, Importer. Okay, so here's the gridded data import wizard. Step one is to navigate to our netcdf files or grib files or whatever we're using. Okay, so here's my project, data directory, and then I want to click on right here. This is my snow water equivalent netcdf file. So I'll click open to that. Next, I want to select the snow water equivalent variable right here and then arrow to the right to select it and then click next. All right, now what I want to do is select that shapefile to crop out just the area that I want, which is what we're doing in this text box here. I'll click the file selector. Then here's my project. I'm going to go into the GIS directory now because that's where we put the shapefile at the beginning of the exercise. Truckee project extent buffered. And then here is that shapefile. And then I'll click open. For the coordinate system, I'm going to select SHG. This is just what the instructions tell us to do, as well as 2000 for the cell size, and then bilinear sampling, and click Next. I'm going to select the destination of my data directory within my project. Okay, here's the project again. Here's the data directory. And then I'm going to give it a name of UA_SWE. All right, now for the path name parts, I need to type in a few things here. How about SHG, Upper Truckee, and then part F is going to be the source. All right, I'll go ahead and click Next. So that's running right now. Okay, we're almost done here. That took about a minute. Then I'll go ahead and close the importer. Okay, I'm curious to see what data actually populated there. So I'm going to open up DSS View and then navigate to that data directory. All right, here's data. And then here is the snow water equivalent.dss file and open. All right, here are my records. So what I'm seeing here is daily data for the snow water equivalent in Upper Truckee. All right, so that looks good here. And this should be for the entire water year. So if I scroll down, yep, it goes through the next September. I'm going to select all the records with Control A and then click on the graph button to see a visual display of that data. Of course, if I hover over a value, I see the color and the number of 0. But if I start clicking through the days, we see the snow water equivalent begin. So we're into November 1st here, and then this would be December 1st. So if I hover over some values, I see 154, 123, 236. So that's referring to millimeters in snow water equivalent for this coordinate system. Okay, just like to peek at that sometimes to see what kind of data that we are using in our model. Now we can go back to that snow water equivalent grid that we created earlier. And then in the data source, we have single DSS record. Let's navigate to that record. Here's the project. And then if I select on the data directory, here is the snow water equivalent.dss file. And then the path, we want to just select the first one and then click the set path name button. Now in my HMS, if I click on the subbasin here and then go down to my components editor, I see the subbasin tab is selected. The snow method I'm using here is gridded temperature index. And if I click on the snow tab itself, we have initial snow water equivalent right here. What I want to change this to is parameter grids. And now I'll have a new field here for initial snow water equivalent grid. From this field, I'm going to select my UA SWE grid. All right, I'll go ahead and save that. We're going to be using this same basin model for all of our simulations, so we'll be investigating that later in this exercise. The next step in the instructions tell us to download and import the temperature gridded data from this PRISM website. So what it tells us to do is click on this link here, PRISM Climate Data website. This is now Oregon State. And then what we want to do is click on recent years. This gives us data from 1981 onwards. If you scroll down a little bit on this page, we want to select mean temperature. And then for the temporal period, not monthly, but we want to click this radio button here for daily data. And then we want to select our year. This is going to be 2017 for February. So 2017 and then February. And then do not choose a specific day because what we want to do is click this link over here that says download all data for the month. And this will be a .bil file. Okay, so go ahead and let that download. This is just going to be February temperature data. And then here is our data. So if I open this up here, we have our .bil files, which we're going to put all of this into the data directory for our project. Let me go there now. Here is the data directory. I'll just drag this zip file in here. And okay, it looks like I already have this in here. Okay, so it's the same file right here. Okay, so I guess it's kind of helping me out. I'll just delete that. But I still need to unzip this file because this is a zip, correct? Yes, it's a zip. So I'll go right click, extract all, and then extract, and it should put it in the same directory here. That looks good. So here is the data that's unzipped. I'll go ahead and delete that zip file just so I don't get confused. Now we need to go back to HMS and create a temperature grid set for February 2017 that we just downloaded from the PRISM website. So here's HMS again. I'll go Components, Paired Data Manager. Instead of precipitation grid sets, I'm going to select temperature grid sets. Now, these temperature grid sets are going to be linked to a meteorologic model, which will be linked to a simulation run. And this RTMA temperature grid is going to be used for one of the simulations. And then our simulation is going to use the February temperature data that we just downloaded. So I'll go ahead and click New. Then I'll give it a name and then Create and Close. So if I go down to my temperature grid sets, there's grid data here, temperature grid sets here. I should now have 3. Yep, this is the one I just created, PRISM, February 2017. As before, I want to select DSS, but I don't have my DSS file available yet. Right now, it's still in a bill format. So let's go ahead and use that importer tool again. So I'll go File, Import, Gridded Data Importer. All right, so let's go ahead and navigate to that bill file. Here's the project data. And then here's the bill file we just downloaded and unzipped. Open. Okay, so all these files are what I want to select. Control A to select them all. Open. And then next. All right, T mean represents the mean temperature. And then next. All right, so let's go ahead and use the same data as before. The same clipping source is going to be our upper Truckee buffered shapefile. The projection here is going to be SHG. The target cell size is going to be 2000, and then bilinear sampling next. Let's go ahead and select that data directory. Okay, just double checking I was already there, data. And then I'll just go ahead and give it a file name, PRISM temp February 2017.dss. Open. Now for the path name parts, I'll go with SHG, upper Truckee, and then now part F is going to be PRISM. All right, next, and it's done. That was quick. So I'll close the importer tool. Now let's go back and assign that data. So we're already right where we want to be. The temperature grid set is selected. Let's go find the DSS file now. Here it is, PRISM temp February 2017.dss and select. Then for the path, this will be the first record and then set path name. All right, just out of curiosity, I'm going to take a look at that temperature data for February 2017. So I'm going to open up the DSS file. Here is daily temperature data. I'll just select them all, click the plot. Now we have temperature. I'm going to make that larger here. Let me take a look at the metadata here. So this is in Celsius, and it's period average because it's over the course of the entire day. Then let's just toggle through some of the days here. So here is the different temperature, average daily temperature in Celsius. If I click on a few here, it's 2.9. That's pretty cold. 3.5, 6, 3. Cool. That's what the instructions tell us to do is create a new meteorologic model. The easiest way to do that is just copy an existing model and change what we need to change. So that'll be a meteorologic model up here in the Watershed Explorer. I'll select WY 2017. And then actually what I want to do is right click, create copy, and then just type in or paste in the name you want for the new meteorologic model, and then click copy. So here is the new meteorologic model. It's an exact copy now of this one right down here. Now what we want to select is gridded temperature, and then change RTMA temperature grid to the one we just created or downloaded, which was the PRISM one for February 2017. All right, so we're ready to create a couple simulation runs since we have two different sets of temperature grids. One was already loaded into the program. The other one we downloaded from an online source and then loaded in to its own grid set and meteorologic model. So now let's go ahead and create two separate simulation runs, run those simulations, and then see how the modeled output snow water equivalent for both those two models compares with the observed data. Speaking of observed data, if I click on the subbasin itself and then click on the options tab, we do have observed snow water equivalent. That's in this time series data set right here. It's not used for the actual compute, but it is used for the plotting and comparison. So we'll see that a little bit later. All right, so let's go ahead and create those simulation runs. I'll go to the Compute Simulation Run Manager. We already have a couple simulation runs here already. That's fine. We're going to create our own. So I'll click New and then give it a name. This is step 1 of 4 when we create a simulation run here. I'll call it February 27 for the RTMA model. This RTMA model, the existing one, uses hourly temperature data, whereas PRISM uses daily. Okay, I'll go ahead and click Next. This is the basin model. We'll be using the same basin model for both simulations. Now what I want to select here for my MET model is the original one that I made a copy from. That's water year 2017. Next, and then the control specification is going to be February 2017 and finish. All right, so the other simulation I want to create is for the PRISM temperature data. So I'll go ahead and click New. I will give this the name of PRISM, February 2017. Next, it's going to be the one and only basin model. Now we're going to select February 2017 PRISM MET model right there. And then again, February 2017 control specification. That control specification could just be for February 2017. So let's see here. It starts on February 2nd and then it goes through the 27th on a 1 hour time interval. This basin model that we're using for both simulation runs, it models the snowmelt with the gridded temperature index method. So we should be able to select the subbasin and then the snow is gridded temperature index. This method uses air temperature as a proxy for the energy available for melting the snowpack. Let's go ahead and run those simulations now. So here is the first one, RTMA, which uses hourly temperature data. Okay, that completed. And then let's run the other simulation run for PRISM. Now let's go ahead and view the results. So up here in the Watershed Explorer, there's this results tab right here. Let me expand the simulation runs. So I'm going to go ahead and click on those. And then I'm also going to expand the element, which is our subbasin element right here. The Upper Truckee River S10 is the name of the subbasin. Now what I want to do is select the snow water equivalent observed as well as the snow water equivalent computed for both the simulation runs. Right here, the observed snow water equivalent. Now let me scroll down a little bit to snow water equivalent. I'm going to hold down the control key here and then highlight that. Oof, that's off. And then let me scroll down to the other simulation results. I don't need to select observe snow water equivalent again, but I do need to hold down control and click snow water equivalent here. So we have 3 different time series data in the component editor. It's really like a preview window. But what's easier is to click the graph button up here in the compute toolbar. And here we have our results. The first record here in solid red is the observed snow water equivalent. This is sort of the target that we want our model to match. The next record down here is the PRISM data. So this is looks like after the beginning week or so, it's well below that solid red line. And then the last record here, the last series is the RTMA run, which used the hourly precipitation. Now, RTMA is much closer to the observed data, but it still is, it underpredicts for a few days, then it overpredicts, and then it underpredicts based on its computed model results. The tutorial mentions that the one reason for this difference is because the RTMA temperature data is hourly and then the PRISM data is daily. In fact, we can look at that data itself. For instance, if I go air temperature, this is the average air temperature in the RTMA model. And then let me just scroll up and select air temperature from the PRISM model. It's right here. So I'll hold down Control and let me go ahead and bring that up in a plot. Okay, so here it is in a plot. I'm going to modify the plot properties here. Okay, so this series is fine. Let's go to the Prism series. And instead of red dash, we could just make it a whole different color, like green and solid line. Okay, apply. Okay. Okay, the green line's still kind of hard to see, but there it is. I made it a little bit bolder by selecting it in the legend here. Now we see that we have daily temperature, air temperature data in the green series. That's the Prism data. And then in red, this is the hourly data. Of course, it's the same data. As you can see, it's basically the same, but the time step affected our snow water equivalent more than I expected. The instructions then go on to give us an option for visualizing gridded temperature results. So let's go ahead and do that. I'm going to just look at this temperature data on a spatial map model, which will be right here using our discretization data. What we need to do first is rerun the simulation and record the actual spatial results. I don't believe we've done that yet. So if I go up into the Watershed Explorer, click on the Compute tab, and then expand the simulation runs, let me expand RTMA and PRISM, the two runs we did. What I need to do is change the spatial results record here from no to a yes. And then same thing for RTMA. I need to change it from a no to a yes. That's save. Okay, good. Now I need to rerun those two models. So here's rerunning the PRISM simulation. That looks good. And then here is the RTMA simulation. Now what we want to do is select our variable from the spatial results toolbar here. If you don't see this toolbar on your screen, you can go up to View, Toolbars, and then Spatial Results. Of course, that's how to hide it as well. So View, Toolbars, Spatial Results, and then select, what was it, air temperature. Okay, so it gives us this warning the first time. Just say, okay, it's just building the tiles, and this only has to happen once. All right, great. So what we see here in the plot is our map, and it has a blue coloration over our subbasin. And we have the player here, which runs from February 2 until the end of the month, February 28th. Now, one thing I don't like about this initial setup is the color range. This is South Lake Tahoe in February, so it's not going to be 100 degrees. In fact, I could just get a quick plot on the temperature range, 40 down to maybe 5. Let me go to a different spot. This is going to range from about, yeah, again, 5 to 45, we'll say. So I'll just go from like 0 to 50. I'm going to set this color range right here. Okay. And then I'll click on the symbology tab. And then I'll say the max is 50. We'll keep that at 0. Apply, apply, apply. Okay. Now our legend down here in the bottom corner is changed from 0 to 50. And I think I can move that. Let's put it in the upper left. Okay. Is that changed? All right. Looks good. Let's go ahead and run the simulation. Click the little play button here. Now, over the course of the month here, it's February 5th, February 6th, we should see the temperatures decreasing, which means the color should be more greens and then blue. This is February 14th, so we're halfway through the month. And then, yeah, here's the greens, and then the blue, it's February 21st, February 23rd, and then ultimately purple, which is like almost 0 degrees. Okay, that's just one different parameter we can select and view the spatial results in a simulation like that. The others are listed in here in this variable dropdown. But that's good for this exercise. What we did was import data, both gridded precipitation data and snow water equivalent data into a few different gridded data sets, into meteorologic models, and then simulation runs. We ran those simulations and then we viewed the results.